we are doing the self-starter on asymptotes again. Find the period and the equations of the asymptotes for y equals 2 secant 1/3 x. Let's talk about what each number means. If this was cosine instead of secant, the 2 would be the amplitude. But because it's secant instead of cosine, it has to do with the range, like the bottom and top range of the graph going the other direction. But that 2 doesn't really have anything to do with this problem. It's just there. Okay, the 1/3 affects the period of the graph because 1/3 means that there is 1/3 of an entire graph in 2 pi. There is 1/3 of a normal graph in 2 pi. That's what the 1/3 means. One more time. There is 1/3 of the normal graph in 2 pi. Okay, so let's do like a normal y equals, if you want to do 2 you can, but it really doesn't make any difference. Why am I doing cosine, not sine? Because it's secant, and secant is the reciprocal of cosine. So the first thing I'm going to do is graph cosine from 0 to 2 pi. So cosine starts at 1, or in this case 2, goes down to 2, goes back up to 2 in 2 pi. Now the reason I graph that is because it helps me remember where those x-intercepts are, because I have a hard time remembering them otherwise. So this would be pi right here. So where is this x-intercept located? Where's that x-intercept? Pi halves. Where's this x-intercept? 3 pi halves. Why do I give a crap about the x-intercepts? Because for cosine, what the x-intercepts are the asymptotes for secant. So now if we look at the graph of y equals 2 secant x, we take and draw asymptotes where those x-intercepts are, and then our graph goes from there. Okay, so the important thing that I'm figuring out from this graph right now is that the asymptotes are normally at pi halves, 3 pi halves, 5 pi halves, 7 pi halves, etc. So they are all a distance of pi apart from each other. So to write an infinite answer, I would just do k pi. Correct? Okay, so now let's talk about the 1/3 and what that does to this answer. 1/3 means there's 1/3 of the graph in 2 pi where there would normally be one graph. So that stretches it out this way, so we would just get one little piece of it, a third of it in 2 pi. I'm not going to graph that part. I'm just going to use that information to do the rest of it. So to do the period of this graph, the normal period is 2 pi. So since there's a 1/3 of the graph that it normally is, we take that number, take 2 pi and divide that number. So we're taking 2 pi and we're dividing 1/3. Which means we get 2 pi over 1, copy, dot, flip. That gives us a period of 6 pi, not 2 pi thirds like a lot of you had written on your paper. Let's think about that and see if that makes sense. If you get a third of a graph in 2 pi, how far does it have to go to get the entire graph? 6 pi, because you're only getting a third of it in 2 pi. So another third in another 2 pi, and a final third in the final 2 pi, total 6 pi for the period, right? Okay, now we do kind of the same thing for the asymptotes. Just like we divided by 1/3, which ended up multiplying by 3 for the period, we also multiply by 3 for the asymptotes. So we go 3 times pi halves plus k pi. So that's the normal asymptotes where they would normally be. But because of the 1/3 and the period being 6 pi, we have to multiply that answer by 3. So just like we had to multiply the period by 3 to get it, okay? Which essentially is dividing by 1/3. Does this all make sense? Multiplying by 3 means we're dividing by 1/3 because that's the number that's sitting right there. Okay, so we get x equals 3 pi halves plus 3k pi, and that's where the asymptotes are.